Hi everyone, this is Mr. Blay again. This is a video on the standard error of estimate. As you can see down here, this is the bottom of your first page of notes. As you can see, this is the equation for standard error of estimate. As you can see abbreviated here with SEST, standard error of estimate. Now it looks like a daunting formula. It looks like there's a lot of stuff to do here. But in reality, almost all of these numbers can be calculated on your graphing calculator. Okay? And there's some steps here that you can basically read through. But what you need to recognize is that these sigmas right here, that this means summation. So you're going to need to just find the summation of your y values squared, summation of your y values, and the summation of your x times y values. The a and the b, those two things are from your regression line. Remembering that our regression line in stats are a plus bx. So the a and the b come from there. N, as usual, is just the total number of data. So if you move to the example problem, okay, and actually I'm going to kind of move this up here at the top of the page so that you'll be able to see that. Well, maybe not. There you go. So you can see the equation. What I'm going to do is I'm going to copy that equation down in the bottom here so we kind of know what we're looking for. One of the things you need to keep in mind with this equation is you need to keep in mind what you're looking for. So summation of y squared we're going to need. We're going to need the summation of y. We're going to need the summation of x times y. In addition, we have to find the a value and the b value that go into our regression line. So in order to do this, I would actually start with your regression line, okay? At this point, you should have an idea of how to find your regression line in your graphing calculator or using Google Sheets, one way or the other. You should be able to find it. Okay. So on your graphing calculator, first thing you're going to do is take all your raw data. This here has to do with different machines, how many years have gone by versus how much it costs to repair those machines. Okay. So in your graphing calculator, you're going to go to Stat and you're going to go to Edit and you're going to input all that data. Now, if you notice, I've already put all the numbers into L1 and L2. So now you're going to have to calculate. Now, when you calculate the summations of your y's, because you want y's, not just x's, when you go to calculate this, go back to Stat and arrow over to Calculate. But instead of doing the normal one variable stats, do the two variable stats. This way it'll give you the summation of all your y values. Okay, so if you click that, make sure you have the correct lists and click calculate. Okay, now you're going to get this whole list. Now you'll notice up here I've got summation of x's and x squareds, but I want summations of y's. So if you go down a little further, okay, now you're going to start getting your summations of y's. So right here, the 496, that is the summation of y. Okay, the summation of y squared is 42,186. And the summation of xy is a little bit further down. It's right here, which you're going to see at 1778. Okay, so those are all your summations. And again, with these formulas, like I said, you don't have to worry about adding all these numbers up by yourself or doing them by yourself. Type your data into L1 and L2, get the summations you need. For standard error of estimate, there are 3 numbers you need. You also need that regression line. Okay, which again I should have done first, like I said, but anyways, you can do the regression line by again clearing out of here, go back to Stat, go back to Calculate, and use number 8. So just scroll down to number 8, or you can hit number 8. Okay, so you'll have your AX plus B. Make sure you use the correct L1 and L2, and then you'll get your A and your B. So your regression line is Y prime equals 55.565 plus 8.13x. Okay, so that's your a plus bx. Now keep in mind what this actually means. So this is basically a y-intercept of 55. So that basically means for a machine that's brand new, you'd only have to spend about $55 a month to maintain it. Okay, and what the 8 is telling you is that after every year that goes by, it's going to cost you $8 more. Okay. So these, the 8 is your B value and the 55 is your A value. All right, so now let's plug all this into the formula. Now again, if you've got your formula, Okay, again, it's at the bottom of the other page, so there's your formula. So we're gonna plug all of our numbers in. And since I just covered up a number or two, I'm gonna rewrite this as 8.13 and A is 55.565. All right, so now plug all 5 of these numbers into their appropriate locations. Okay, so you've got the square root of everything. You've got the summation of y squared, that comes first. So you've just got 42186 minus A, which is 55.565, times the summation of y, which is 496. And then you have minus again, and you got B, which is 8.13. And then you have next to that is the summation of xy, which in our case is 1778. Okay, and all of that then gets divided by n minus 1, which in our case is 6. Sorry, not n minus 1, n minus 2, okay, which is 6 minus 2. Now again, it's 6 because in our data, if you look, our data right here, there's 1, 2, 3, 4, 5, 6 pieces of data. So that's why it's 6 minus 2. All right, and then you start to calculate. Now, be careful about calculating the top here. Make sure when you calculate it, make sure you do your multiplication first, then your subtraction. Okay? Or if you're gonna punch it all in at once, make sure you use appropriate parentheses. Okay? So again, if you're using appropriate parentheses, just to kind of show you what that would look like. Okay? In your calculator, 42186 minus, make sure you put these both in parentheses, 565, and then 496. And then you minus again, put these in parentheses, the 8 point, and then the 1778. So you should get, as a numerator, you get the number 170.62, and as a denominator, you get 4, which then will give you, divide that by 4, you're at 42.65. So your standard error of estimate is, in our particular case, we'll square root that answer, and we're gonna get about 6.5, okay? So now just as a explanation as to what we get here, let me move this up a little bit so you can see slightly better, okay? Just as an explanation here of what the 6.5 means, okay? So what this means, just to give you a brief explanation, let's say I graphed this, okay? Now I'm just gonna put 6 random dots here and just give you an idea of what we mean here. And let's say this was my line of regression, okay? So let's say that's what the graph looked like. What a standard error of estimate does is it takes the distance from a physical point back to the line. Takes this distance, this distance, this distance, this one, and this one. And what it does is it takes all these 6 distances and it basically averages the distances. So in other words, what it's actually doing is it's taking every data value and it's basically just figuring out how far are your data values from your regression line. Okay? Which basically means in this one, our data values up here are only an average of 6.5 units away from the actual line itself. Which means as an average, that's actually really good. Okay? That means all of our data values are quite close to the linear regression line. And if you actually go back into stat, calculate, and 8, I'm gonna show you our correlation coefficient because this kind of matches up. You can see our correlation coefficient right here. It's 0.9, 0.92, almost 0.93, okay? That's an extremely strong relationship, which this also shows because it's showing that your average distance from your regression line is only 6.5 units away, which is actually very, very close to that regression line, meaning your correlation or connection between your true data and your regression line has a very strong connection. Even your coefficient of determination, saying 85% of your y values are being explained by your x values, okay? 85% is a lot, okay, out of 100%, obviously. So these all kind of connect together. So it's important to recognize what that standard error of estimate is truly representing in your data. Hope this helps, guys.